Here we go again. The elements. A visual exploration of every known atom in the entire universe. This was a long time coming, and now we're going to go ahead and start off with element number 81, aka thallium. Now, thallium is the first acutely toxic element ever since arsenic. Yes, there are other elements that are not really good for you, such as mercury or selenium, but they won't knock you flat out dead. Yeah, in other words, it's a perfect murder weapon. You can go ahead and make it into a perfect murder weapon, like arsenic, except arsenic became a victim of its own symptoms. It's so obvious what arsenic poisoning looks like. Now you go ahead and you can just immediately test the person for arsenic poisoning, and boom, you got it. The trick to poisoning someone is end up getting away is to poison them without them knowing that they're going to get poisoned. And it's a poison whose symptoms that no one just recognizes, and eventually we found that out in arsenic. Arsenic was used for hundreds of years, but then people just realized that, yeah, they're very obvious, and so they needed a new replacement. That's when thallium came in. Now, thallium itself, on the other hand, stays obscure much longer. It murders people, it's colorless, it's odorless, and its most famous thallium murders occurred in 1950s. It occurred in the 1950s. But thallium poisoning cases, both intentional and accidental, kind of stunned the police for years, for like decades to come. Mainly because, well, even today they are confused. Yes, of course, tests are readily available for thallium testing, but you have to suspect it before you can even think of testing it. And here are the symptoms towards thallium poisoning. They are, as listed: vomiting, hair loss, delirium, blindness, abdominal pain, each of which you notice is a symptom of other diseases and health conditions as well too. The signs of murder by lead are generally much more easily recognizable, mainly because they're usually bullets. Atomic weight is 204.3833, the density is 11.85, its atomic radius is 156 picometers, and its crystal structure, well, it's a hexagonal prism. Well, 5F has been skipped, 6S is starting to go into 6P, and I should note that thallium has, on average, slightly lower melting point than other elements do. It does still have a standard boiling point, though. Not very standard. Speaking of lead signs of death, here we go. Lead itself is really common nowadays, mainly because of bullets. Lead themselves are used in plumbing until we realized that they were poisonous, and then they were well done. As few as 2 grams of lead inside your body is lethal, at least when it's delivered from a barrel of a gun. Lead is the preferred metal of the bullets, mainly because it's quite dense, allowing a lot of mass to fit into a little bit of space. It's really useful too because it has a low melting point, which lets it being put into molds quite easier. Less heat needed to turn into metal, well, that turn into a liquid, well, that's really useful for casting stuff. Is it very durable? Yeah. It's soft enough to fit tightly in the gun as well too, without, well, getting jammed or something. It's only half as dense as osmium or iridium, but these bullets are too expensive for the United States military to afford. That's why the lead is being used. Lead is cheap enough and dense enough that they are used in special armor-piercing rounds, which we will discuss later under uranium. Another time-honored notable thing about lead is that, well, lead-based murder was popularized by the board game Clue, a lead pipe. Yeah, lead pipes are really literally right there. Lead pipes have existed for centuries. The Romans have used them in the original days. And this may sound exotic to us because nowadays our pipes are made of iron or copper. But back then, lead was the preferred metal as well too. Drain pipes made of lead have been in service of the city of Rome since Roman times. And it doesn't mean that the type of lead pipe for 2,000 years. It doesn't mean that they have been using that kind of lead for 2,000 years. It's that the actual pipes have been there for 2,000 years. And they last virtually forever. Lead itself is an ideal metal for pipes, mainly because it just doesn't stick stuff onto it. Considering how much we've discussed poison over the last few elements, maybe it comes no surprise that lead itself is toxic. Not only for the fact that it's lethal, but it's toxic as well too. It's a prototypical heavy metal poison. And touch it, well, nothing's, well, you're fine, but eating it, yeah. However, after 3 elements of poison talking stuff, we'll finally arrive to something that's very opposite. The atomic weight is 207.2, density is 11.340, its atomic radius is 154 picometers, and its crystal structure, it's a cube. 6p is starting to be filled up. I really hope it's filled up by the end. And we have very low atomic emission spectrums. It has a very low melting point, which is why we use them to mold our shapes into bullets. Alright, this is a lead glass teardrop of ornament. This contains 33% of lead, yet it is completely transparent. The lead increases the index of refraction, which makes the glass more sparkly. Alright, bismuth. Bismuth itself is very beautiful, mainly because of either its rainbow colors, and people drink a lot and lots of it, mainly because, well, they just really want to have the feel for it. They want the feel for it. They want to cure their upset tummies, which it's kind of controversial whether it works or not. For all practical purposes, though, the active ingredient in Pepto-Bismol brand upsetting stomach medicine is that, well, it's bismuth. It's bismuth. It's 57% bismuth by weight. This is really odd when you consider that the element to the left of bismuth is lead, which is so toxic that entire toy industries have been turned on their heads trying to eliminate it. And the one onto the right is polonium, a deadly radioactive poison used in recent times by a Russian bad guys to eliminate inconvenient people. Well, that's very ironic, mainly because that's in the middle, smack middle of those poisons. But it is kind of beautiful too, and it has really great properties. Pepto-Bismol goes ahead and does not get its name by accident. The active ingredient is bismuth subsolite, which for some reason people drink a lot to cure their upset stomachs. 30-pound ingots of pure bismuth are how the metal is often sold commercially. Broken in half, they can be shown with broken, beautifully internal crystals. That's very beautiful too. And sometimes there's these kinds of rocks that you can find naturally, and they show all those rainbow colors very beautifully. Its atomic weight is 208.98038. Its density is 9.780. Its atomic radius is 143 picometers. Its crystal structure, it's an oblong cube. 6p is starting to be filled up. I really hope it gets filled up, please. At least let my satisfaction be there. And boom, it has very low atomic emission spectrums. It has an even lower melting point and slightly higher boiling point. Next up, we have polonium. Polonium, as mentioned earlier, was discovered by Marie Curie and Pierre Curie, the Curie wife and husband duo. They go ahead, and it occurs naturally with uranium ores, and they went ahead and named it after Marie Curie's homeland, Poland. These brushes are used on phonograph records and film negatives to dissipate static charges that attract dust and mounted just behind the bristles of these things. This is a Lone Ranger atomic bomb spectral ring, which was offered as a Kick Serial premium in 1947. Basically, you can also use them in anti-static brushes, but this is how it's made. Polonium itself is very toxic, so you should never let it come out. It's protected by a layer, it's inside 2 layers of gold. But you're thinking, how did they get the polonium inside there? Well, they didn't. They just created it inside there. They made sure there was something inside the gold, and then they did some chemical reaction, which made the polonium exist. Polonium itself is really useful in these anti-static materials. The half-life is only 138 days. So old ones like these anti-static materials, ones that were created with polonium, are practically useless after 138 days. Polonium spark plugs were gimmick and have completely lost their radioactive by now because, well, polonium, it's terrible. It's terrible. They lost all their radioactivity, so it won't last really long. It only lasts like 1/3 of a year. The most common isotope of polonium, so polonium-210, is so radioactive that a solid chunk of it glows from the excitation of the surrounding air. A single gram puts about 140 watts of power continuously, but that's nothing compared to the next element we'll see. But before that, its atomic weight is 209, its density is 9.196, its atomic radius is 105 picometers. It has a crystal structure of a traditional cube. Yeah, traditional cube. It's slowly filling up 6p. Its atomic emission spectrum, it's kind of not very, it's very, very, very low. Also, it is moved to the left a lot. It has, for metals, for elements at least, it has a really low melting point. And traditionally, until now, we saw boiling points all the way here. But now we're seeing them all the way here. I know, before we didn't even see a boiling point. But then again, that was sublimation. Finally, we have astatine. What are you seeing? What you're seeing right now is fluorescent uranium minerals, which may or may not contain an atom of astatine at any time. Astatine is the first of the 4 really frustrating elements for element collectors. Those are francium, actinium, protactinium, and radon. They're slightly annoying too, but not quite as much. Astatine is considered naturally occurring. After all the elements for hydrogen and uranium, except for technetium. But its half-life is only 8.3 hours, which means that whenever astatine occurs, it doesn't naturally just stick around very long. A rough estimate indicates that at any given time, there's about an ounce of it present in the entire Earth, and it's never the same ounce from day to day. The supply is constantly refreshed by the slow radioactive decay of uranium and thorium, of which there is vastly more. The typical solution for element collectors is to display a radioactive mineral specimen containing uranium or thorium and wave their hands around them, talking about how there's probably an atom or 2 of astatine inside of it. Also, I'm not sure why you would want that, so it's much more likely that there isn't. Of course, of all the North American crustal plates to a depth of 10 miles, there are roughly about 1 trillion naturally occurring astatine atoms at any one time. Yeah, I don't think this is worth all that trouble, despite its short half-life. So astatine itself is being studied for use in radiation therapy for cancer. This seems less surprising when you consider that technetium-99 is widely used in medicine and is just as short as a half-life. So practically, there's no practical uses for astatine right now, nothing worth talking about it. And that's all I can say about it. So that is the end of astatine, and we'll talk about the stats. The atomic weight is 210. Density is so short that we never got to measure it. Its atomic radius is 127 picometers, and we don't know its crystal structure because we never were able to measure it. And since we can't measure it, well, we only know of it as a solid, and the atomic emission rate is terrible. Well, at least we know its electron filling order. 6p is almost full. And that's it. I hope you guys enjoyed this episode. I hope to see you guys soon. Until next time, Shalom, peace. Bye-bye.